Welcome to the VG tutorials. In this video, I will show you the basic workflow for a CT reconstruction. The scan I want to reconstruct is a USB stick that was scanned in a cone beam scanner setup. First, I will open VGSTUDIO MAX. To launch the reconstruction dialog, I go to File, CT Reconstruction. The dialog consists of several tabs with a wide range of options, but don't worry, we will only need a few of them. So let's start with the Reconstruction Approach tab where you can specify the general settings. Since we want to reconstruct a scan from cone beam CT, I will select cone beam CT as the general system geometry. For all other options on this tab, I can keep the default settings and proceed with the Projection Files tab. As the name suggests, you will load the projection files here. To load the projection files, I click Load Parameters, browse for the folder where the parameter file is stored, select it, and click Open. The projection files will be listed in the Projection Files section. The number of added projection files is displayed at the top of the list. Okay, all files are there. The settings in the lower part of the Projection Files tab are taken from the header of the projection files and should already be set correctly. The only option I want to activate additionally is Projection Smoothing, here at the bottom right. Projection smoothing can be helpful if the data is too noisy. I'll activate the checkbox and select Low from the drop-down list as a first try. We will view the result later in the slice preview. But first, let's take a look at the projection preview. To open the preview dialog, I will click the Projection Preview button here at the bottom of the CT Reconstruction dialog. The projection preview gives you a first impression of whether the reconstruction parameters are set correctly. If they do not match the actual scanner setup, you might not get a preview at all. The preview section shows two orthogonal projection images surrounded by blue frames. What I want to do now is cut away unneeded areas of the projection data. To do so, I click and drag the blue frames around the images closer to the volume to define a region of interest or ROI that only contains the object. Keep in mind that you should always leave some air around the object to prevent parts from being cut off during reconstruction. On clicking Apply ROI and Orientation, the ROI will be applied, and the frames will turn blue again. There's another line shown in the preview images that indicates the height at which the detector offset will be calculated. If the default position in the middle of the object does not show a slice with good contrast or an area of the image that contains no sample, you can use the Projected Slice Position for horizontal detector offset calculation spin box to move the magenta line to another slice position. The horizontal detector offset will then be calculated at that position. And that's it for the preview. CT images often show artifacts caused by a misaligned geometry of the CT system. To correct this misalignment, you can go to the Geometry tab and adjust the Scanner Geometry Correction parameters. But first, I want to make sure that the Automatic Adaptive Detector Binning checkbox is unchecked. Based on the dataset properties and the geometric setup, this function automatically decides whether it makes sense to use a detector binning. But keep in mind, using binning in reconstruction reduces the resolution of the reconstruction and may therefore affect measurement accuracy. Now, back to misalignment correction. That sounds complicated, but VGSTUDIO MAX will do all the work for you. In the Scanner Geometry Correction section, I just check the Automatic option next to the Horizontal Detector Offset field to let the software automatically calculate the misalignment correction. The next tab, the Reconstruction Options tab, provides several options to compensate for artifacts that might appear during reconstruction. I would always recommend that you apply a speckle removal to get rid of any defective pixels. For that, I select On Multi-Pixel from the Speckle Removal drop-down list. Ring Artifact Reduction is also a good option. I will start with choosing Low from the drop-down list. If you are not sure which option to select, you can view the result in the slice preview. But let's set all parameters first and view the slice preview in the end. When performing long CT scans, the X-ray tube might flicker or the radiation intensity might change during the scan. To compensate for such fluctuations, you can use the Compensation for Radiation Intensity option. I'll choose Peak from the drop-down list. VGSTUDIO MAX will search for the air peak, that is, the mean value of the background in the image, and each projection image will be normalized to its air peak. For short CT scans, you can set the Compensation for Radiation Intensity option to off. Finally, I will activate the Beam Hardening Correction. This option can improve results, especially for high-absorbing parts or parts with undesirable penetration lengths, such as flat or thin objects. Which preset to use depends on the scan. I will start with low. To view the effect of the settings made so far, I will open the Slice Preview dialog. The Slice Preview will show a preliminary reconstruction of the selected slice using the current settings. Since calculating the preview might take some time, a projection skip and a reconstruction skip are predefined to speed up the calculation. Don't worry, the skip functions do not affect the actual reconstruction. They are only used for calculating the preview. You can use the Slice Position spin box to view several slices. When you change the settings on the Reconstruction Options tab, the preview will update accordingly, and you will directly see how they affect the selected slice. Actually, the result looks fine to me. I will close the Slice Preview and proceed with the next tab, the ROI and Skip tab. At the top of this tab, the previously defined region or ROI is highlighted in orange. The orange color indicates that the ROI has already been specified in the projection preview. I could use the X, Y, and Z spin boxes to change the position and dimensions of the ROI manually, for example, if I wanted to reconstruct only one slice. We can ignore the skipping functions in the lower part of the tab. You've probably considered carefully which settings are useful for your scan and don't want to change the resolution or omit any projections. The last important settings are provided by the Result Options tab. In the clamping section, you can specify the lower and upper clamping limits for the reconstructed gray values. As the predefined values already make sense, I can keep them unchanged. The reconstruction will be internally performed in 32-bit float format. In the Result Data Type section, you can choose how much you want to downsample the result. But I recommend that you keep the 16-bit default setting, unless you want to reduce the gray value resolution in favor of a smaller result dataset. In that case, you could select, for example, 8-bit from the drop-down list. Finally, you will have to specify how the result should be saved. For now, I only want to import the reconstruction result in the current scene and save the result slices later. Therefore, I'll select Write to Disk Later up here from the Import Mode drop-down list. For finally saving your reconstructed object, you can choose from two options. You can either save each slice as an individual image file, an image stack, or all slices in a single file. I prefer saving my result slices in a single file. For this, I will have to change the volume export mode by clicking Change Preferences. This will launch the Preferences dialog directly on the CT Reconstruction Properties page. Here, I'll select the Merge Image Stack in One File option. When I close the dialog, my selection will immediately be applied to the Volume Export Mode field of the CT Reconstruction dialog. And that's it. I have made all necessary settings and can click Finish to run the reconstruction. A progress dialog will appear showing what currently happens. The misalignment correction will take a while before the actual reconstruction starts. And here is our reconstructed USB stick. You can save the project by selecting File Save. A file browser will open, where you can select a path and file name to save the scene to a VGL file. After that, you will be asked if you want to save the modified volume data. I will click Save to save a raw file containing the reconstructed volume. And that's it. Now you can work with the reconstructed volume as you're used to and perform analysis or measurement tasks. I hope you enjoyed this tutorial. If you want to learn more about CT reconstruction, check out our tutorial overview page via Help Show Tutorials and take a look at the following documents. Concept and Technologies, CT Reconstruction Parameters. Tutorial, CT Reconstruction Preview Volumes and High-Resolution Reconstruction of Regions of Interest. Plus, make sure to register on Nexus and make it your go-to place for sharpening your expertise. Get access to this video and other information material to get the best out of our software. And visit the VG community to exchange ideas, ask questions, and discuss topics with other users and our Hexagon experts. And stay up to date on the latest news and developments. Register now, a world of insight awaits. Thanks for watching, and see you soon on Nexus.